Welcome to my solar addiction. Today's video:
Sol-Ark 15K versus EG4 18K PV, Part 1. Who will win the title?
Today's video is the EG4 18K PV versus the Sol-Ark 15K. A comparison from someone who has run their house on both inverters.
Tonight, we are going to witness the most anticipated match for the heavyweight championship of the world. Are you ready? Let's get ready to rumble!
In this corner, the 18K PV made by EG4 Electronics. It has similar specs to the opponent, the Sol-Ark 15K. Today's video has been in the making for a while. I have personally lived with the two Sol-Ark 15Ks, running my house for over a year. And after running my house on those for over a year, I'm now doing the same thing, running my house with two EG4 18K PVs with the same battery setup. And today we're going to do a comparison video between the 18K PV and the Sol-Ark 15K. Now, there was a recent video out, and by somebody that I highly respect and have learned a lot by watching his videos over the years. And he had some points he made about the 18K PV that I didn't agree with. He made some points that I did agree with. And I'm going to go through point by point my opinion as someone who has lived with both inverters running their house. Not just trying to push it as far as you can with a compressor made for industrial work or, you know, something that's not most people would use in their house. So it's more of a real life comparison as far as running a house, which is what most people are going to buy these things for. So let's get started.
As I promised, we're going to go over several points that were mentioned in the previous video, comparing these two inverters, and let's look at those points. The first one we're going to talk about is overall build quality. These units are very similar. You're going to see that. And we're going to talk about how similar they are in build quality, which to me is important. I like quality equipment. I don't want to own a piece of junk. I believe in paying for things once, not twice, because if it's going to break real quick, you're going to have to buy it again. But so build quality is something we're going to go over. And then we're going to discuss why the specs are a little hard to actually compare if you're just looking at the spec sheets, because they're definitely not laid out the same way. Then we're going to go over the important specs that were specs for debate. The power output is a very important topic we have to cover because I don't think it was covered properly. And then the cost per kilowatt hour, which is going to give you which one is the better value, I also think that wasn't calculated properly. Some of the power output numbers skewed the cost per kilowatt number, so we need to go over that. And then the PV power input was a big point of discussion, and I'm going to show you that it's really negligible between both of these units. It's going to be based on the actual numbers of not just the inverters, but the solar panels themselves will determine how many strings and how many panels in a string you can do. And then the ease of installation is also an important factor, especially if you're doing DIY solar. So we're going to go over that. And in that section, there was an issue of the 2-aught cable. He made a big deal out of making ferrules, putting ferrules. He's never used 2-aught on any of his inverter installs, and that it was such a strange thing to him. We're going to show you that it wasn't strange and that Sol-Ark actually recommends using 2-aught. And then we're going to go over the monitoring software, what I like about the software for each one of them, There's pros and cons on both. And then we're going to talk about another issue that came up, the server location. A lot of people are worried about their information going to China, and that China might just shut their inverter off, and they would love to have US based servers. So we will discuss that. And then in conclusion, I will give you my opinion of both of these inverters. I have lived with both of them, connected to my house. I've run all of my appliances. I try to live completely off grid with grid as backup, because my goal is always going to be total energy independence. That is what I'm working towards. I'm at that 90-something% range of being off the grid for the full year, and I can't wait to get to the 100. So overall build quality, let's look at the interior of these inverters. We could see that they're laid out pretty much the same. The only real difference is that the control board for your comms and your battery communications and your CTs is in a different location. The EG4 has that board to the left of all of its breakers, and the Sol-Ark centers it towards the middle. And if you look, the breakers are very similar. They're both nice, well-made breakers, the load breakers and your battery breakers on both units. They both use really nice PDBs, power distribution blocks, for their load grid and generator connections, as well as battery connections. The only differences in the MPPTs is the way they connect, which the Sol-Ark uses the kind of Wago style connectors, and the EG4 uses the push style, and you have to actually put in ferrules on it, which he made a big deal out of. To me, it's not a big deal. Putting ferrules on things is not a problem. But they basically kind of laid out the same, and the quality of the interior parts are very similar. So that's the inside of them. The left side of each unit is very similar layout. We've got our PV disconnect or DC switch, which is going to turn off your PV. And then you have the on-off button, which on the EG4 says RSD, rapid shutdown. They both can do the same thing. And then there's the Wi-Fi dongle. They both have Wi-Fi dongles, so you can have that communication with the internet. Now, let's look at the other side. The right side of each unit, they have the latches to close the compartment where all of our wires go, our wiring compartment. And the EG4 has locks on it, comes with a key. They're a little bit nicer latches. You can lock the Sol-Arks by buying little locks. There's a little loop for you to lock it and slip through those latches. But I do like the EG4 latches a little bit better. Let's move on to the screens. So here is the screens on both units. I personally like the Sol-Ark a little bit more because at a glance I can see my numbers a little bit better, and that might be because I'm getting a little older and my eyes aren't that good. But if you look at them close up, let's look at the EG4 closer up. You can see that they have more data at a glance. So if you like that more data at a glance, that's going to be important to you. You got your totals for the day and your totals for the actual production for the entire unit for however long you've had it. At a glance, you can see that on the face of the unit itself. To me, that's not as important because personally the screens are something I'm not going to use. I tend to use software to look at my inverters and what they're doing. But like I said, the Sol-Ark's a little easier to read at a glance for what's happening PV-wise coming in, how much energy is coming from the grid, how much energy is going to your loads, and how much energy is actually translating to your batteries. But it's like I said, I don't stand in front of the inverters very much, so it's probably not a big deal to me. It may be a big deal to you, but those are the differences, and I do have a slight preference for the way the Sol-Ark is laid out. Now, let's look at these specs. These are the two spec sheets, and you can see that they're a little hard to compare because you have things laid out differently. The EG4 is actually 2 pages. That's the first page. Here's the second page. And, you know, you have to go mix and match and move things around for you to actually make a comparison. So as we go through each group of specs, the important ones to our discussion, we're going to have them on a spreadsheet so that we can quickly see the comparison, and let's do that now. So the first thing we're going to discuss is AC output, and this is a very important factor in determining which inverter you want. Now, they both have very similar specs. Let's start top down. They both have 200 amp bypass or grid pass through. The nominal AC voltages are going to be the same. They both can do single phase 120/240, or they could do three phase 120/208. The grid frequency, same. The max continuous power from battery alone, no PV, this is very important, is 12K for both inverters. Did you catch that?
That's the fact, Jack! That's a fact, Jack!
No PV, battery alone, these are both 12K inverters. But wait a minute, I thought it was a Sol-Ark 15K. It says max continuous power from battery with PV. So the extra 3K is coming from the PV, but there's one thing that they didn't mention. If you have no grid connection, that's not true. It's still 12K. Bet you didn't know that, right? Yeah, it needs the grid connection for it to add the extra PV energy to that continuous power, because they fluctuate too much. You got clouds passing by, you know, the PV has to have something to regulate that, and it uses the grid connection to do that. So if you're off grid completely, no grid connection, and have a Sol-Ark 15K, you have a 12K inverter. All right? Both of these can start my 4-ton train unit. They needed a soft starter because of all my other loads. Once they started kicking in, the AC started struggling. And I just decided, because I wanted some headroom, I don't like to run my inverters to their max all the time. I want to have about 80% is the maximum that I want to push it. So I want to have that 20% headroom. So 2 inverters always made sense for me, no matter which ones I went with. And that's how I run my system. So I don't have to push them so hard that they break. Plus, it'll help me with some longevity. I also get a little bit of, redundancy. If something goes wrong, I could take one out and put the other one up and just run on one leg, So you have to understand that extra 3K, you need a grid connection. If you don't have a grid connection, both of these units are 12K inverters. So let's look at some surge numbers. Now, the surge numbers are different. And notice it says that peak power with batteries alone for 30 minutes, the Sol-Ark can do 13K, but that's not continuous power. So for 30 minutes, it'll give you that 13K, but that's not a number we can use to calculate our cost per kilowatt hour, because it's not continuous. But it does do a peak for 10 seconds off grid for 24K, and then another peak for 100 milliseconds off grid, you can get 30K. The EG4 says peak power with PV, we can get 14.7 for 10 minutes and 15.5 kilowatts for 5 minutes. And then without PV, the EG4 can do 13.5 kilowatts for 10 minutes. So the Sol-Ark can do, without PV, 13 kilowatts for 30 minutes, but this EG4 18K PV can do 13.5 kilowatts for 10 minutes. So you got to know your surges, you got to know your loads to be determining which one of these is going to work for you. So let's look at cost per kilowatt hour. So if we look at these numbers, this is the comparison that he made. The EG4 18K PV, which was EMP hardened, would be $48.98 is kind of the list price. But Signature Solar often offers that 5% discount. And so that number would be $46.53, which if we divide it by 12K, which is the continuous output, we get $387.75 per kilowatt hour. And then if we use Practical Prepper's 15K number, they only charge $6K for their Sol-Ark 15K, non-EMP hardened version, by the way, which would give us $400 per kilowatt hour, which makes the cost between the two very negligible if we're going by kilowatt hour, cost per kilowatt hour. But if we really analyzed it apples to apples, if we took the EG4 18K PV, which is EMP hardened and has passed the test, and the Sol-Ark 15K EMP version, which even with the discounted price on Practical Prepper's website is $8,000, which we would have the Sol-Ark coming in at $533.33 per kilowatt hour versus $387.75 per kilowatt hour with the EG4. Now that's a big difference. We need to compare apples to apples. And if we really want to be comparing apples to apples, we're not going to use 15K as the number to divide our cost to get a cost per kilowatt hour, which would look more like this. Okay? So if we analyze it at 12K for the Sol-Ark and use the EMP version, then we get let's use his discounted price. We get $666.67 per kilowatt hour versus $387.75 per kilowatt hour for the EG4 18K PV. That's almost double. So that's why I put this part at the bottom where I have two EG4 18K PVs in parallel like I have in my house now. And that would give us 24K of continuous power with 2 units. And we compare that to the EMP version of the Sol-Ark 15K, and we got the same cost per kilowatt hour, but we have twice the continuous output. So if you really need that much more power, you need, somewhere between 12K and 24K of continuous output off grid, the grid connection, no PV added in because you need the grid connection to make that add in. You would have for about $1,300 and $1,306, you could have 2 EG4 18K PVs for the price of 1 discounted Sol-Ark 15K EMP version. That's a big difference. So let's compare apples to apples. Let's not forget that the money was spent to actually test the EG4 18K PV and their batteries, which one of the reasons why I love their batteries, and I think that people don't include that in their cost comparisons, saying that EG4 batteries are so expensive with all these other batteries coming out so cheap. The same thing applies. You got to compare apples to apples.
Thank you for watching. Hope you enjoyed our video.
Click the link to continue with part 2.